You've been working on naming ionic compounds and writing formulas for ionic compounds, and that, as you know by now, is quite a bit of work, especially writing the formulas, because you have to stop and figure out what is the charge on this ion and how can I crisscross my subscripts to make sure that I have charges that balance out and so forth. But today we're going to look at compounds where the electrons are being shared, so we don't have ions, and you're going to find out that this is ever so much easier. But before we get started, we have to learn some prefixes, and I think you're going to see some of these prefixes look pretty familiar to you, especially as you get into geometry, because there are a lot of the same prefixes that you've used in math classes. So the prefix for 1 is mono, prefix for 2 is di, for 3 it's tri, for 4 it's tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So you get those written down so that we can use them. And then once you've finished writing them down, we'll start working on some examples. So let's take, for example, a compound that looks like this. It has 1 sulfur and 6 fluorines in it. So we want to name this in a way that tells people that it has 1 sulfur and 6 fluorines in it. So we will name this sulfur hexafluoride. Now let's stop and see what we did here. I used a prefix here to tell me that I had 6 fluorines. I still use the IDE suffix on the second element, and we'll be doing that all along. There are no polyatomic ions to worry about here. We're only going to have 2 elements. But every time, the second element will end in IDE, so we'll continue to use that. And the first element will just have the name of the element. It's not going to change. Now, for prefixes, we always use a prefix if there's a subscript. If there is no subscript, we could use mono. But here's the tricky part. And I don't know who made up this rule, but we just have to roll with it. We use mono only for the second element. We never use mono for the first element. So I'm not going to say mono sulfur hexafluoride. I'm just going to say sulfur hexafluoride. However, look at this one. CO. C is for carbon. O becomes oxide, but I need, and I'm not going to put 2 O's in a row because that's weird, so I drop the O on mono and write monoxide. And that's a familiar compound, carbon monoxide. That's that toxic stuff that if you breathe it in, it'll kill you. So 1 carbon, but we don't need mono for that. 1 oxygen, and we do need mono for that. Now look at this. Also a familiar compound. Now you're familiar with that already, so you know the name is carbon dioxide, but now you can know why it's carbon dioxide because we're going to use the same rules. Carbon, we don't need the mono because it's the first element. Di, because that's the prefix meaning 2. And then oxide, using the IDE ending for the second element. So pretty simple, right? Now, it's even simpler going the other way, because if you know the names, if you're given the names, it's very easy to write the formulas, because all you have to do is identify your 2 elements, then remember what the prefix means and use that as a subscript. So let's try a couple of those. Let's say that I am given the name phosphorus pentachloride. So phosphorus, I have already memorized that that's a P. Chloride, familiar at this point to know it's a Cl. Penta means 5, so there's 5 chlorides, but there's only one phosphorus because it doesn't have a prefix, so phosphorus pentachloride. How about nitrogen dioxide? N for nitrogen, O for oxide, 2 oxygens, NO2. So this is ever so much easier than doing these ionic ones, so I know you'll have a much happier time doing homework on this section.